Everything you think you know about reality is wrong. Well, not wrong exactly, just incomplete. At the tiniest scales, the universe operates by rules so bizarre that even Einstein refused to believe them. Particles that exist in multiple places simultaneously. Objects that affect each other instantly across the galaxy. Reality that doesn't exist until you look at it. This is quantum physics, and it's about to break your brain. Quantum physics is the science of the incredibly small, atoms, electrons, photons. At this scale, the everyday rules stop working. Gravity becomes irrelevant. Things can tunnel through walls. Cause and effect get fuzzy. The quantum world is like a video game where physics glitches are the actual rules. Everything you're made of follows these bizarre laws. Here's your first mind bender. Light and matter are both waves and particles at the same time. An electron isn't a tiny ball orbiting an atom, it's a probability wave. A photon of light isn't just a particle, it's also a wave. Which one you observe depends on how you measure it. It's like asking if water is wet or liquid. Yes, particles are whatever they need to be. This experiment broke physics. Shoot electrons one at a time through two slits at a detector screen. Logic says they'd hit in two lines, but no. They create an interference pattern like waves, even though they're going through one at a time. Each electron somehow goes through both slits simultaneously, interfering with itself. Watch it and it stops. The act of observation changes reality. Quantum particles exist in superposition, meaning they're in all possible states at once until measured. An electron isn't in one place. It's in a cloud of probability spread across space. It's simultaneously here and there and everywhere in between. Only when you measure it does the particle choose a location. Reality is optional until someone's watching. Schrodinger created a thought experiment to show how ridiculous quantum physics seems. Put a cat in a box with a quantum device that might kill it. Until you open the box, the quantum device is in superposition, of triggered and not triggered. Therefore, the cat is both alive and dead simultaneously. Of course, the cat knows if it's alive, but quantum weirdness scales up in strange ways. Measuring quantum particles changes them. This isn't about clumsy instruments. The universe literally doesn't decide what state something is in until it's measured. Before measurement, particles exist in fuzzy superposition. After measurement, they collapse to one state. Reality is created by observation. You're not discovering what was there. You're forcing reality to choose. Einstein called this spooky action at a distance. When two particles become entangled, they're connected regardless of distance. Measure one and you instantly know about the other, even if it's on the other side of the universe. It's not that information travels fast. It's that they share the same quantum state. Change one, the other changes simultaneously. Faster than light connection without sending signals. Heisenberg discovered something fundamental. You can't know both a particle's position and momentum precisely at the same time. The more accurately you measure where it is, the less you know about where it's going. This isn't a measurement problem. It's built into reality. Nature has fundamental limits on knowability. The universe is inherently uncertain. Particles can teleport through barriers. If an electron encounters a wall it shouldn't be able to pass, sometimes it just appears on the other side. It's not going over, under, or through. It's using quantum superposition to exist on both sides simultaneously, then collapsing on the far side. This is quantum tunneling, and it's how the sun produces energy. Particles have a property called spin, but they're not actually spinning. Quantum spin is an intrinsic property like charge or mass. Electrons have spin up or spin down. But in superposition, they're both up and down simultaneously until measured. Measuring spin also demonstrates entanglement. Quantum spin is weird even by quantum standards. Einstein helped create quantum physics, but never liked it. He famously said, "God does not play dice with the universe." He believed reality must be deterministic. not probabilistic. He challenged quantum mechanics for decades, proposing thought experiments to prove it incomplete. But every test has proven quantum mechanics right, and Einstein's objections wrong. Even geniuses can be wrong about reality. Quantum physics isn't just theoretical. It powers modern technology. Semiconductors and computers rely on quantum tunneling. LEDs emit light through quantum processes. MRI machines use quantum spin. Lasers are quantum devices. GPS satellites account for quantum effects. Your entire digital life exists because engineers harnessed quantum weirdness. Weird physics makes practical technology. Regular computers use bits that are 0 or 1. Quantum computers use qubits that are both simultaneously through superposition. A 3-qubit system can be in 8 states at once. 300 qubits could be in more states than there are atoms in the universe. Quantum computers could crack encryption, simulate molecules, and solve impossible problems. The quantum revolution is coming. Quantum mechanics enables unbreakable encryption. Send entangled particles to 2 locations. Because measuring changes quantum states, any eavesdropper would inevitably disturb the system and reveal themselves. You'd know instantly if someone intercepted your message. China launched quantum communication satellites. Banks are adopting quantum encryption. The observer effect becomes cybersecurity. Here's a wild idea. Maybe particles don't collapse to one state. Maybe all possibilities happen, each in its own parallel universe. Every quantum measurement splits reality into multiple branches. In one universe, you're reading this. In another, you clicked away. Every decision, every quantum event creates new parallel worlds. You exist in infinite versions across the multiverse. Probably, quantum effects might be essential for life. Birds may use quantum entanglement in their eyes to sense Earth's magnetic field for navigation. Photosynthesis uses quantum coherence to transfer energy with near-perfect efficiency. Even DNA mutations might involve quantum tunneling. Smell might be quantum. Life isn't just chemistry, it's quantum chemistry. Biology harnesses the weird. Empty space isn't empty. The quantum vacuum constantly produces virtual particle pairs that pop into existence and annihilate within fractions of a second. These quantum fluctuations are real and measurable. They create the Casimir effect, where 2 metal plates in a vacuum attract each other. Even nothing is something in quantum physics. The void is alive. Here's the big unsolved question. What counts as measurement? When does superposition collapse? Does it require a conscious observer? Or does any interaction count? Is observation special or just another physical process? Physicists have debated this for a century without consensus. The measurement problem is quantum physics admitting it doesn't fully understand itself. Despite being bizarre, quantum mechanics is the most precisely tested theory in history. It's made predictions accurate to 15 decimal places. Every experiment confirms it. It's never been wrong. Scientists don't fully understand why it works, but they know that it does. Quantum mechanics is proof that the universe is under no obligation to make sense to human brains. Quantum physics reveals that reality at its deepest level is profoundly strange. Particles are waves. Things exist in multiple states. Observation creates reality. And somehow, this bizarre quantum foundation gives rise to the stable, predictable world we experience. You are a quantum system that became complex enough to wonder about quantum systems. The universe is weirder and more wonderful than we ever imagined. Subscribe to explore more quantum mysteries.